Hello everybody, welcome back to my YouTube channel. Today in this video we are going to discuss brute force approaches. In that we are going to first discuss exhaustive search. This exhaustive search is it's a brute force approach to a combinatorial problems. It suggests that we have to generate each and every element of the problem domain and we have to select those of them that satisfy all the constraints, and then we have to find the desired element. If we have given one problem, then we have to find all the possible paths to solve this problem. We have to consider all the possible paths. We have to find all the possible paths to solve this problem, and then we have to choose those paths which satisfy all the conditions. Then that will considered as our optimal solution to our problem. Okay, this is what the exhaustive search describes. In this, we have three types of problems to be solved. That is traveling salesman problem, knapsack problem, and assignment problem. In this video, I am going to discuss traveling salesman problem, and in further video, we will be discussing these two topics. Okay, let's look into our traveling salesman problem first. Now let's discuss the traveling salesman problem. Here what traveling salesman problem is telling is that here the traveling salesman problem asks to find the shortest tour through a given set of n cities that visits each city exactly once before returning to the city where it started. Here the traveling salesman has n number of cities to be traveled. He has to travel to n number of cities. He has to visit each and every city exactly once, and he has to return to the same city from where he has started. Through this, he has to find the shortest distance or shortest path to travel each and every city and returning to the same city. To return to his same city, he has to find the shortest distance or shortest path. We may say that. Okay. Here the problem can be conveniently molded by a weighted graph, with the graph vertices representing the cities and the edges weights specifying the distance. Here we can visualize this problem using a graph also. Here we can visualize this problem by graph. Let's consider these nodes as the cities. Okay. These nodes as the cities and vertices as the path. The traveling salesman, let's consider the traveling salesman is starting from this city A. Okay, he has started his traveling from the city A, and he has to he has to visit each and every city exactly once, and he has to travel to his city from where he has started. Okay. And to travel this he has to find the shortest path. Now let's understand this traveling salesman problem by using this graph. Here we have four cities named as A, B, C, D. Now the traveling salesman has to travel each and every node exactly once, and he has to return to the same city from where he has started. Now let's consider the traveling salesman is traveling from this node A. Okay, and he has to find the shortest path or shortest distance. Now we have here tours and here the length. These edges are the paths or distances he is traveling from one city to another city. In first case, he may travel from A to B, B to C, C to D, and from here he can go back to the same city from where he has started. This path can be written as A to B, B to C, C to D, and D to again returning to the same city, that is A. Now, from A to B, the distance is A to B 2 plus B to C we have B to C is 8 plus, then C to D the distance is 1 plus, again D to A, that is he is returning to the city from where he has started traveling, that is 7. Then if we add this, we will get 18. This is how we have to calculate the distance. Okay, let's now consider another path from the same city he is traveling, that is from A to B, B to D, D to C, and C to A. right? From where he has started, from he is returning to the dead city only. Now this path can be written as A to B, B to D, D to C, and C to A, right? Then if we calculate the distance, the path A to B, A to B is 2 plus B to D, B to D is 3 plus D to C, D to C is 1 plus and C to A 5. We will get 11. We will get 11 as the distance, total distance he has travelled to visit each city. Now the next path will be A to C. He can travel from A to C, C to B, B to D, D to A, right? Here A to C, C to B, and B to D, and D to A, right? If we calculate the path, A to C is 5 plus C to B is 8 plus and B to D is 3 plus D to A is 7. Then we will get 23. Okay. Now next path, we have to calculate each and every path. Okay. Now from A to C he can travel, from A to C, C to D, D to B, and B to A, right? A to C, C to D, D to B, and B to A. A to C, the distance is A to C is 5 plus C to D, C to D is 1 plus then D to B, D to B is 3 plus B to A is 2, then it is equals to 11 again. And another path will be A to D, D to C, C to B, and B to A, right? A to D, D to B, D to B, B to C, C to A, C to A. Then the total distance will be A to D. A to D is 7 plus D to B is 3 plus B to C is 8 plus C to A is 5. Then we will get 23. Okay, and another path will be A to D, D to C, C to B, and B to A, and their distance will be 5. A to D is 7 plus D to C is 1, D to C, and C to B is 8 plus B to A is 2, which will be equals to 18, right? Among these paths we have to take those paths which is making a shortest distance. That is, here you can see, if we compare these paths, the 11 is the smallest distance the man has travelled, right? Then these two paths will become the optimal solution for this problem. These two paths, okay, because we have got the smallest or the shortest distance. This is how traveling salesman problem work. Thank you for watching my video. Please subscribe to my YouTube channel. Thank you.